So what happens whenever we place solid steel wool, which is mostly solid iron, and place that into a solution of aqueous copper 2 sulfate? So at this point, you may want to pause the presentation and watch that YouTube video available in the lecture slides. First, what we need to do is understand what is present within the aqueous copper 2 sulfate solution. Copper 2 sulfate solid dissolves into aqueous copper 2 plus ions and aqueous sulfate 2 minus ions. So in the reaction, you may have made a couple of observations. We see that we actually have copper 2 plus aqueous ion reacting with the solid iron in order to produce solid copper and iron 2 plus aqueous ions. So based off of your observation, you could have seen a change in the solid in that reaction, or maybe you observed a color change of the aqueous solution. Either way, you made observations telling you that a reaction occurred. So when we assign oxidation numbers in this reaction, we can see that copper 2 plus will have 2 plus for that oxidation number. Iron solid is an atom in its natural state, a solid, so this will be an oxidation number of 0. For copper solid, this also will be an oxidation number of 0. And for iron 2 plus, this will have the oxidation number of plus 2, or 2 plus. So in this reaction, we see that copper 2 plus on the reactant side became copper 0 on the product side. So this is indicating gaining 2 electrons. And the reason why I know that is because we went from a plus 2 to a 0. So if I gain 2 electrons, I'm becoming less positive with each electron that I'm gaining. So gaining 1 electron would then result in a plus 1. Gaining 2 electrons results in this 0. So we gained 2 electrons from copper 2 plus over to produce copper 0. This process is called reduction. So we would say copper 2 plus was reduced to copper 0. Likewise, iron solid, or iron 0, became iron 2 plus. So if we're going from a charge of 0 to a charge of 2 plus, we are becoming more positive, which means that we are losing electrons. And specifically, going from the charge of 0 to 2 plus means that we lost 2 electrons. So we call the process of losing electrons oxidation. So we would say that iron solid was oxidized to iron 2 plus. So this is the fundamental concept behind redox reactions, where we have this paired process of oxidation and reduction. We see that some oxidation numbers will be changing over the course of a reaction from the reactant side to the product side. So copper 2 plus, we said, was reduced to become copper solid, and the species that is reduced we end up calling the oxidizing agent, or we could also say that copper 2 plus is the oxidant, meaning that copper 2 plus is what is oxidizing the other component in this reaction. And likewise, iron solid became iron 2 plus and was oxidized, so then iron solid is what we call the reducing agent. Iron solid is performing the reduction on the other component. So we see that these are paired processes. So revisiting this, we've identified that the oxidizing agent is associated with the reduction half reaction. So for this specific example, copper 2 plus was reduced to copper 0. Whenever we're looking at these half reactions, we call them half reactions because they are associated with half of the redox process. We need to make sure that we balance the charge on each side of the reaction. Remember that this was something we had to do all the way back when we learned about balancing reactions. We need to make sure that we balance the charge. And here we balance charge by including the electrons in the process. So copper 2 plus was reduced to copper 0 by gaining 2 electrons. So copper 2 plus 2 electrons that are -1 in charge, a +2 and a -2, ends up equaling the charge of 0, which is what we see is the charge on the product side. Copper solid has an oxidation number of 0. So copper 2 plus gained the electrons, and we see that the oxidation number becomes more negative. Meaning, when we gain electrons, we go from a more positive number to a less positive number or a more negative number. So in this case, we went from +2 to 0. Now, the reducing agent is associated with the oxidation half reaction. And for the oxidation half reaction, we had iron solid yielding iron 2 plus aqueous ion, and in order to balance this half reaction, we are including the 2 electrons on the product side. We have to do this in order to make sure the reactant side and the product side have an equal charge. And in this case, if iron solid has a charge of 0, well then iron 2 plus the 2 electrons on the product side will equal the overall charge of 0. So this will always be the case. For the reduction half reaction at the top, you will always be including electrons on the reactant side. And in the oxidation half reaction on the bottom, this will always be the case for the oxidation half reaction, where the electrons are always going to be included on the product side. So again, iron solid lost electrons, and when it loses electrons, it becomes more positive. Right? In this case, we went from a charge of 0 to +2 because we lost something that was negative, the electrons. And when we lost the electrons, we're showing them as a component on the product side. So we went from 0 to +2 for that oxidation number. So let's talk about some mnemonic devices. I know students always really like to have ways to memorize the components of these half reactions. So there are 2 really popular mnemonic devices for redox reactions. We have oil rig, where oil stands for the oxidation half reaction is losing electrons, and the rig part of it stands for reduction half reaction is gaining electrons. So if we remember the first letter of those, we can always remember oxidation is loss of electrons, reduction is gain of electrons. Now the other very common one is usually the one that I use, and it says the same thing pretty much. This one is Leo the lion says grr. So if we remember Leo and grr, this is very similar. Losing electrons is oxidation and gaining electrons is reduction. You see side by side that these are saying the same exact thing. So it may be helpful to choose one of these to become familiar with in learning about redox reactions. Now, I want to point out the differences between reducing agent and oxidizing agent. I know it's always very confusing thinking about the reduction half reaction and the oxidation half reaction with identifying the reducing agent and the oxidizing agent. Now, when we're looking at these, you have to keep one thing in mind. The term agent means that that species is responsible for carrying out that process. So the reducing agent is the agent that is responsible for reducing something else. So if it's reducing something else, that means that it is getting oxidized. And likewise, the oxidizing agent is the agent that is oxidizing something else, which means if it's oxidizing something else, it is being reduced. So when you're thinking about these, you always should be thinking about this as a paired process in which electrons are simply being transferred from one thing to the other. So in this case, iron solid transfers electrons to copper 2+. We can see that in the equation at the top, where iron solid lost electrons and was oxidized. So if it's oxidized, it has to be the reducing agent. And copper 2+ gained electrons, so it was reduced. And if it was reduced, that means it is performing the oxidation on something else. So one way you can think about this is you have to have someone else doing something to you in order for that process to occur. A reducing agent can't be reducing itself, right? It has to be interacting with another species in order for something to occur. So this is a common point of confusion when you're identifying what is reduced versus what is the reducing agent, etc. So let's get back to this reaction, right? We had copper 2+ aqueous ion plus 2 electrons yielding copper solid. We identified this as the reduction half reaction. So we see that in the reduction half reaction, it will always be true that the electrons are on the reactant side. And for the oxidation half reaction, we have iron solid yielding iron 2+ aqueous ions plus 2 electrons. The oxidation half reaction will always have the electrons on the product side. So if we're looking at these two half reactions, we see that the 2 electrons on the reduction half reaction actually will cancel out with the 2 electrons in the oxidation half reaction. So if we want to identify the net redox reaction, we are just adding everything on the reactant side to everything on the product side with omitting anything that is present on both sides. So for this case, the 2 electrons cancel out. So the net reaction we have is copper 2+ aqueous ion plus iron solid yields copper solid plus iron 2+ aqueous ion. So this is the net redox reaction, and in order to do the net redox reaction, we have to always have the balanced half reactions, meaning that the electrons have to cancel out. They have to be the same number.